I will start. So what is execution counting? Execution counting is a feature in zTPFGI which allows developers to detect which source lines have been executed and how many times those source lines have been executed. So it differs a little bit from certain tools. Certain tools will allow you to see whether a line has been executed. This will do that. Also, it will allow you to see how many times the line has been executed. It's sort of a developer-oriented tool. It's made to be easy for individual developers to use to analyze their own code. It allows the developers to see the effects of changes they make to their source code on these numbers, that is, which lines are executed and how many times. And it allows developers to document and communicate these numbers, these facts to other people, to their colleagues. So how can you use it? Well, you can use execution counting to see if things are happening as you expect. For example, I expect this function to be called. Is it called? You know, execution counting can show me that. I can detect hotspots in the program, so I can see which lines are being executed a lot more than others, and that might lead me to do some kind of a coding efficiency, or realize I don't need to call that as much, or I might take it. If it's a function, and this works for assembler too, but today we're going to use C++ as our example program. It allows us to. It would allow me to perhaps, okay, I won't do that as a function. I'll do it in line or something like that to make it more efficient. Execution counting also allows you to compare before and after changes, and we'll look at that, and then document the changes you've made, the effects of changes you've made, and communicate and report the effects of those changes to your colleagues. So let's get started for the demo. Well, let me just say one more time, the benefits of execution counting. So you can detect certain types of errors early, perhaps, like forgetting to call a function or subroutine. You can detect whether all the lines have been hit that you expect to be hit while you're testing. And hopefully, this will allow us to produce efficient, more error-free programs. So to set up, you do need to be connected to a system, obviously, in zTPFGI. And you have to have the program that you want to trace be loaded, and then add the members to source view trace. Those are the basic things you need to do to get ready for execution counting. So I have a little, very simple kind of toy test program here. It consists of three files and a couple of header files, and execution comes here first, and then it calls file B, and file B calls file C, and file C does some things that don't really matter, but they could. I mean, we're pretending here. One of the things this file C does is to calculate a factorial and call a certain function that many times. So that will hopefully let us look at what hotspots look like and things like that. So first, turning on execution counting. To turn on execution counting, you can turn on execution counting for individual members, individual files or programs. The first thing you need to do before you turn on execution counting is to make sure you've added those files to source view trace. So I'm going to go to my load sets view and select some files and right click and say trace and source view. There's several ways to to lock programs in for source view trace. This is just one of them. So right now we're waiting for the host to respond. Great. Okay. We're going to lock in the programs that we want to test and that we want to run execution counting on. Okay, so now we've got the programs added to source view trace. You can see the lock icons here and up here. To get it into execution counting for those programs, there's several ways to do it. I'm going to right-click over here, hover over execution counting. Now I've got a couple of choices here. I could toggle execution counting for this one member, this one program or file, or I can turn on execution counting for all the members that I put into source view. And so that's what I'm going to do because that's a little faster. Just click once. So now we've turned on execution counting for those three members. So you can see the icon has changed. This is how you can know you're in execution counting. It becomes more colorful both here and over here. So now to get into trace, to get into my program to intercept the ECB, normally you would probably run a transaction in a terminal to hit your program, or you might do an asynchronous trace. This is a very simple test program. I'm just going to create an ECB to get into it. So I'm going to create an ECB for program PRG7. This ECB stopping is not really a part of the process. So let's see. So we're here, and now, okay, as usual, we stop once in the program to allow trace to be set up and so forth. But I'm just going to run this so that we can see the execution counts come in. We're just going to run it to completion. Okay, so this is run to completion. You can see different counts in the columns. We call this the execution bar, and this shows the counts. It also, you can right-click it to quickly get to the commands. There's one execution bar for each program or member for which trace is turned on. Now, so you can see that we color code the lines with what we call a heat map. You can select different heat maps. Let me just show you that quickly. You can go to execution counting properties. What I did was right-click on the execution bar. You get the options for execution counting. And then these color scales. You can do the rainbow. You can do sort of blue to red, sort of light yellow to red, and grayscale. Let me put light yellow to red on to show you a different one. It's really up to you, whatever you prefer. I'm going to switch back to the rainbow because I think it makes a slightly better demo. You can also choose whether to color the entire line or just color the execution bar. So you might find it distracting to have all the colors all over your code, so you can turn that off if you'd like to. Once again, I'll just turn that back on. Okay, so now we have counts for one run through the program for each of the files that we had execution counting turned on for. Okay, so yes, now I want to explain about clearing the counts. And there's an option to automatically clear the counts. So right now, I have the count. Let me go back to the properties. I have the option turned on to automatically clear the counts. that means that the next time I run, when the new counts come in, they will start again from 0. So if I create another ECB, we'll enter the program again. So we've entered the program. Now I know the counts still say 6 and 5 and 1 and so forth, but really they've started over. And if we run to the end, when we get the new counts, we see that these new counts are 1, 1. So they're the same because we started over from 0 and we didn't make any changes to the program or to anything else to cause these counts to be different. Now, it's also possible to accumulate the counts so that they don't start over manually. I mean, clear the counts manually. So let me go back to execution counting properties. We'll turn off automatically clear execution counts. And let me just manually clear the execution counts just for clarity here. Now, we'll create the ECB. We'll run through. And you can see the numbers vary from 1 to 6 in this particular area. Now we'll create another ECB, and this will show the numbers accumulating. And we'll run. Now they vary from 2 to 12. You can see they've doubled because we've accumulated them twice. You might find a use for that. You might want to see what happens when you run a program multiple times. Say there might be some noise in the program based on how it's being used by the system or something. You might want to run it multiple times and see what the average number of counts is if you run it 10 times, or the total number of counts. I don't know, but I'm going to clear the counts manually here. Okay. So now, what can you do? You can notice that certain things were called or not called. Now, what I had originally meant to do, I'd meant to leave it set up like this for the first test, for the first run through. That that this function up here would not be called, and we would be able to notice that. I forgot to do that, so I was going to go and show you, oh, look, this function was not called. I meant for it to be called, and so then I was going to go down here and make the change and show you again. So I kind of ruined the surprise there. So, it really did happen to me, actually, that I put this function in, which, is pretty meaningless in terms of this program, but could represent something real in a program. And I'd forgotten to call it. It happens all the time. You extract some code, put it somewhere, you mean to call it as a special subroutine, and then you forget. Well, one thing execution counting can do is, oh, I noticed there are no colors on that line. So that can clue you in that here's a mistake waiting to happen. But the function is being called. So let me run these. Let me run these counts. Let me run these counts one more time, and I'll start to show you the reporting feature. Okay, so I have some counts. Now, if I want to save these counts, I can, and not just have them go away the next time I run, well, that is, save a record of them. I can right-click and say, Save Execution Counts. Let me do that again in case I did that too fast. Right-click, Save Execution Counts is right here. So I'm going to select that. Then we get a dialog box that's asking us to name the file, and we can provide a description. So I'm going to say, I'm going to provide a description because I've got a change in mind that I'm going to make to the program that I haven't made yet. I'm going to say before factorial change. Okay, and I'll say save. Now those counts have been saved to a file. If you want to see, if you want to try to see that file, you can right-click and say Manage, Export Data. These are older ones that I was using for testing. I'm going to delete those. Okay, so this is the one I just did. You can see the description over here is before factorial change. You can see which programs had execution counting turned on for them, what the system was, what the time was, and so forth. Now, I'm just going to go ahead and export this to Excel to allow you to see what that looks like when you're just exporting one set of data. There's some options down here. You can export to Excel, export to a PDF, and choose to open the viewers immediately after you export. I'm just going to export to Excel, so I'll say export. And this is asking me to name the file. And now the Excel viewer, or if you had Excel on your machine, Excel itself would open up. The Excel viewer has opened, and we have a report. The report has 4 pages in this case. The report will have one summary page and one page for each member for which execution counting was turned on. And then there can be some other pages which I'll show you in a few minutes in certain situations. But this first report tells you what the members were, where they're located, the total number of execution counts that occurred in those members. And you can see the description up here before the factorial change. Now for each member, we've got a display that's very much like what you see in zTPFGI. So it will show you the counts for each line. And here, that's the third one. A common question is, there's source lines here. If I go back over in this report, if I go back over to zTPFGI and I change the source code here, is that going to change the source code in this report? And the answer is no. That when zTPFGI saves the counts, it also saves the source code lines. So you don't have to worry that changing your source code will change the report. So you can save this, you can save it for yourself, you can send it to someone else, and not worry about the data being corrupted later by something like that. I'm going to close that. Now I'm going to clear the counts because I've got it on manual right now. Let's go in and make a simple change that will result in a big change in our execution counting. So this number that we're passing to B, which B then turns around and passes to C, which is then used and we calculate the factorial. Right now we're passing 4. Well, if I change it to 8, that doesn't seem like a big difference. I'm going to save that. And this is representing a small change you might make in your program that might have a big effect. This is obviously not something that matters in the real world. So now I've saved that, and I've got to rebuild my project. And I'm going to load it. Now, here I recommend that, when you're making the change and you've built it and you're reloading, to choose refresh, because right now, as you remember up here, we've got several files locked in, and we've got several files with execution counting turned on. We don't want to have to relock them and return it on. If we choose the refresh option in this dialog, in this load set creation dialog box, zTPFGI will do it for us. So I'll say OK. We have to delete the load set that's added right now, and then we need to load the new load set, the rebuilt load set. So that's coming in. Here we can see in the load sets view, the members are being relocked, and then execution counting was automatically turned back on for us. So that's convenient. So we've made our change into factorial from 4 to 8. I'm going to create the ECB. And we're going to stop in the program. There we are. We'll let this run to completion because we're just interested in the numbers. We did increase that factorial number. It might be a communication issue, so let's just wait a moment. There it goes. Okay, so we can see in this file the numbers are the same. Nothing changed here. We wouldn't have expected it to. And in this one, nothing changed. It's in this one that, hey, wow, suddenly we have a big change. I think it was about 24 before. Now it's 40,320. Quite a large change. So let's say this was significant. We want to show that, we want to document that this particular change was good or bad. And then we might want to communicate that to someone. So we'll save these execution counts. And we get this. I want to show you something that will happen. This is what we expected, and this is good. Let me say that I forgot to save the execution counts, and I went right to Manage Export Data. You see, this is the first file we saved. I've forgotten to save my data. But down here, there's a link that says, do you have unsaved counts? Click here to save. So if you do go right to Manage Export Datasets and you forgot execution count datasets and you forgot to save your counts, there is a link that will let you sort of save the day here. Although I could close and go back and save the counts. But I'm just going to click this link. Then we'll get the, I'm going to say after the description, after factorial change from 4 to 8. And I'll say save. I'll say save and export. That will bring up the next dialog right away. Okay. So this first dataset file represents the one I just did. We could export this by itself, just like we did the first one, but we can export them both together. And we can do that by multi-selecting. So what I'm doing is I'm holding down the Shift key while I click, or you can hold down the Control key also while you click. Now both data sets are selected, and I will also export to PDF this time. And we'll say export. First we're choosing the name of the Excel file. Now we're choosing the name of the PDF file. And first the Excel viewer popped up, and now the PDF viewer popped up. The PDF viewer has the same content as the Excel. It just depends on what you prefer. I'm going to go ahead and show it to you in Excel. So I'm going to close the PDF viewer. Now we have 2 data sets in the summary page. You can see the large count here for the revised version, and we have more pages now. We have one page that says Set 1 PRG7A. So this is the first data set that we created. this is the counts for that for file A in the first data set we created. This is the counts for file B in the first data set we created. This is the counts for file C in the first data set we created. I'll talk about the colors in a minute. This is, and then we go into set 2, and this is the counts for set 2 for each of those files. Then, okay, so then we have a new set of pages here, which is comparing the counts. So we have 3 more pages. One is comparing PRG7A in set 1 and set 2 together, PRG7 and PRG7B in set 1 and set 2. So you can see side by side the counts compared in each run. And this is where the interesting differences are. The reason that we've got the reason that most of the numbers are blue in this display, and there's only a few red, is that these reds are they're all the counts are it goes from a very high of 40,000 red down to a very low of 1. It just turns out that on that scale, almost everything is very low. There's nothing that nearly compares to 40,000. So the 40,000 lines came out red. Those are the real hot spots. The other lines came out some various shade of blue, which looks like the same shade of blue, because those lines are very low compared to 40,000. But this does point out that the differences that you need to pay attention to. Obviously something significant changed here. Okay. That is the basics of execution counting. I'm sure there may be some questions. We obviously haven't done a real-life example, but hopefully it has been enough to show you how to turn it on and off, how to work, and how to work with it. So be happy to take questions now, if anyone has some. If you do, I guess type them in. Okay, I'm not seeing any questions yet. I'll wait just a moment longer. Wait, okay. Let's see. Okay, we've got a question. The question is, I assume this will work the same way, whether you use source file listings for source view trace. And that is a good question. I believe it will. Yes, it should work the same either way. Absolutely. Okay, I see another question. Let me try to give them the right to ask a question audibly.
Ed, excuse me, Ed. Can you hear me?
Yeah.
Ed,
Yes, I can hear you.
the question was, some segments are very large. Is there a limitation on size when exporting to Excel or PDF? This was a question from Joyce. And following it, the third question was, will this work for ASM programs, from the next person?
I understood the first question. I'm going to need you to repeat the second question. Is there any limitation? Is there any limitation on size? Was the first question.
Yes. The next question was, will this work for ASM programs?
Yes, it should work for async programs. What you'll need to do is, it should definitely work for async programs. When the program stops, and Kartik could correct me if I'm wrong, you could turn on the trace then. or if you know what, yeah. So I mean, you can lock in for trace at that point when the ECB stops. Yes, and Cardic R confirms that it will work for async trace as well. And that's how you would do it. And I'm sorry, Chitra, what was the second question?
The same question was repeated again, Ed. Like some segments are very long. The second question was repeated as the fourth question, and the third question was again repeated as the fifth question.
We don't have a limitation on size. We did see a delay in the data coming back, but I think that was a function of my connection. I imagine it probably would take a little longer for the data to come back when the program was longer. But there should be no limitation on the side of getting the file and keeping the data in the file and so forth. It will work for simpler programs, and it will work for listings.